Hello everyone, just a quick follow-up to a previous tutorial about topic 3. I just wanted to build a little bit on our discussion from class, but also use an example that's coming through from the student work as a way to kind of help everyone out moving forward. Just to reference what we're going to do, we're going to build out this sample here that we can see on the mirror board. And as we discussed, the logic of this is relatively straightforward. We're basically taking the points out of the square, finding a midpoint for each edge, treating the corner points sort of like anchor points, and then moving those midpoints in toward the center, either a little bit or a lot, all the way toward the middle, in order to create the sort of effect across the surface. Okay, so let's walk through a version of this. And as we discussed, there's more than one way to do it, so I'm sure some of you will have a different technique for this. But this is a technique that was started by someone in the class, and I thought that I would kind of carry it on and share some of the office hours conversation, just as a way to kind of to see if anyone else had similar questions. Just going to start right off from the surface here. This is our typical, subdivision and deconstruction of those subdivisions in order to find things that we need to start with, and we'll do a couple things. First, we know we need the center point, right, judging from what we just looked at, and we also need those edge midpoints. So I'm just going to go over to surface up here and grab that area component, plug that into my faces, and I'm also going to just kind of visualize the edges. So I'm just going to grab a curve parameter here and just show that so that I can turn off some things, get rid of some of the noise on the screen visually. And I'm also going to need these to find the midpoint, so I'm just going to go ahead and go to curve, and you should be able to find this curve middle. If not, you can use the point on curve component as well. It will also give you the center point. So there's our midpoints and our centers. Okay, so we have a kind of little bit of a start here. Now what we need to do, because we're starting with rectangles, if we had squares, perfect squares, we probably wouldn't need to do this step. But because we have rectangles, I'm going to need to measure how far we are from this point to that point and from this point to this point. There are going to be different distances. And if I want to use a single slider to control all of that, I can just set a limit that doesn't allow it to go beyond those distances, respectively. Again, multiple ways to do this, but I'll try to simplify it a little bit by setting a limit. And in order to set the limit, I need to know how far they are away, so I need to know the distances. So we can go over to vector here, and we'll find up top the distance component. Okay, and I'm just going to go ahead and measure, how far away I am from the midpoints in the data tree. So each 4 of these are going to be compared to the center, and it'll get a range of distances out in the same kind of data structure as we have here. Then what I can do, I can also use those points as well to create a direction, a vector direction. So I'm going to go to vector here, and I'll use my vector 2 point, because I need to direct the computer what direction I'd like to move these points in. And because we're on a surface here, I can't just use one of the, x, y, or z vector vectors, unit vectors. I need to kind of customize that. So what I'll do is set the center here as the B, as the end of that vector, right, the kind of target point, and I'll set the midpoints as the A input there. All right. And that'll get us started. The next thing I'd like to do is, before I forget, is to kind of be able to give some control over this move, so that it's not a full move from point to point, but I have some space in between that I can move the point, right? So kind of build up the gradient, as we can, again, kind of see here. So these points have only moved a little bit, these have moved a little bit more, these have moved a bit more, and then these have moved a lot, these have moved 100%. Okay. So while we're in the vector tab here, let's grab our amplitude. Okay. And our amplitude is where we can set our, we're going to use this distance information. I guess I'll pull this up here. And we'll set our minimum value. So I'm just going to, I guess I can go over to Math, Utilities, and Minimum here, and the value. What this is kind of a funny thing because the minimum component in a way sets a maximum because what it does is it returns the smaller value. So it's looking for the minimum value, and it will always output the minimum, which in a way sets up a kind of max value that we can't exceed. So I'll use a slider for that. I'll just use a default slider between 0 and 1. I think that should work here. And that'll be how we're going to control this, at least for this first part. We can go ahead and put that then into our amplitude there. All right. Maybe I'll organize it this way a little neater. All right, then we need a move component. All right, so let's go over to transform, Euclidean move. What we're moving is going to be those midpoints. So that's these over here. So sometimes I like to clear an area, you know, do something like that. And then go ahead and bring that over. And the target, the translation vector is going to end up being these, the result of what's coming out of that amplitude component. And I guess to clean up my previews a little bit, I'll start turning off some points. And then if I go ahead and move this, what I should be seeing is, there we go. Yeah, so no matter how far, and you can see that the ones, let me zoom in a little bit. These two here are going to get there a little bit faster, right? So now they touch and they don't go any further, even though I'm continuing to move the slider, right? So that's what's set by our minimum value there, right? So that's pretty nice. Now all we really need to do is connect the dots around. And I'll show you a little trick for this. I mean, you're welcome to do it manually. You can associate a point, you know, you can list out the points, kind of like what we showed before with surfaces. We can kind of list those out, 1, 2, 3, okay? And then all 4 points are here. And you can associate those points with the corner points, which you can also list out. And you could connect the dots manually. But a little trick to this that might be a little helpful is to kind of weave together the two sets of points, because the way that the edges and the points, the corner points, are organized is in the same order, and it should be such that if this is the 0 point, this line here should be the first line in sequence. So that means this midpoint will always be next in line after the corner. And I can use that logic all the way around to just kind of weave the two sets together and then draw a polyline. So let's play that out to make a little more sense as we go here. In fact, one thing that we might be able to do also is number those points just to kind of give you a sense of it. Here's a little moment where you don't necessarily have to follow along. I'll just kind of show you. But I'm going to go to display and use this point list component here. And I'll turn that off for a moment. And maybe I'll turn up the size on these a bit. Oh, that's a little big. Yeah. So there you can see the order of the points, the midpoints. So that means that the lines are in the same order. Let's take a look at the order also of the corner points. And those are going to come from over here, these vertices. Right, so let's check that out. And there's going to be a bit of overlap, unfortunately. So one thing that we're going to do, I suppose we can do is kind of isolate out one of these boxes and run that again. So I can do just this, and then I'll find basically where that one is. Let's see where it is. Probably going to be down at the bottom corner somewhere. Yep, there it is. All right, so that allows me to go ahead and show, you know, gives me an idea for the order of the corner points that match up to the order of the midpoints. And you can see that it's 0, 1, 2, 3 counterclockwise and 0, 1, 2, 3 counterclockwise. This is ideal for weaving. So if I weave the first set, the vertices, it's going to bring that in, and then it's going to weave the other ones in. So it's going to go 0 to 0, and then 0 to 1, 1 to 1, and then 1 to 2, 2 to 2, 2 to 3, 3 to 3, 3 to 0. And it's going to come back around again until I can draw my polyline. All right. This isn't always the case, you know. I mean, of course, you need the right kind of conditions for this to be set up, but in this case, it works well, and we can go for it. I'm just going to delete this stuff out. Don't need it. put that back on. If your computer lags a little bit, go ahead and kind of delete that point component, the point list component, and or just disable it. It should speed up a little bit more. Okay, so let's go ahead and weave it. So I'm in the Sets tab here, and I should find that in the list, and down here in the middle at the right, weave. By default, the pattern that's set up here is 0, 1, so it's going to start with the zeros and then weave in the ones. So remember that what we need then is to start first with the corner point. So I'm going to grab a point parameter here and bring over my vertices. And to keep my script nice and clean, I'm just going to make like a little daisy chain here. So I can do something like that, bring it over nicely, and bring that in there. And then all these moved points should weave right in here. And now I've got a node full set. So all that goes green, as you can see. And the result of this, check it out. Instead of having, right, if we go over the result here, every one of those pads on the right, or on the left, all has, each one of them has 4 points. That makes sense. And each one of these has 4 points. And now when we weave them together, we get the same kind of output in terms of the number of paths on the left, but now each one of them has 8 points. So we've kind of combined the 2 sets per square, 2 sets per square. All right. And we should be good to go here just to kind of draw the polyline. So I'm going to go to Curve, Spline, and Polyline. And I'm going to draw that. Now you can see that, of course, it doesn't quite finish itself off yet, so you can right-click over the C input here and change that Boolean value to true. And just in case it's missed in my audio here, I'm just going to make sure that you see it all that way explicitly. And you can see now the pattern being drawn out across the surface. I'm going to go ahead and turn those edges off so I can see it that way. Maybe that's a little nicer. And then I can play with my slider here just to kind of watch it turn from basically squares to a diagram. So it transforms from one to the other and everything in between. So now we're pretty much ready for adding the ability to control it with a gradient. So we can use a path mapper for, a graph mapper for this. And we'll do that in the next step. So I'm going to make this a 2-part bonus tutorial. So I'm going to stop here and we'll pick it up at the next step.